Hey, what's going on, folks? It's Mike here, and welcome to the programming language series First Impressions, in which we look at a programming language for the first time and just get an initial impression for about an hour. And today I'm very excited to be looking at the Crystal programming language. So without further ado, let's go ahead and dive into this programming language. And I will admit, I honestly do not know anything about the Crystal programming language. This is a language that's been showing up in the comments on YouTube. I did a little bit of research on it maybe a few months ago because it's another up-and-coming systems programming language, but honestly did not know about it, but it seems like a really nice language. So I want to learn more. I hope you'll join me on this journey, and let's go ahead and dive in here. And I'm going to go ahead and start where I usually start, the wiki, because, well, Wikipedia gives a nice overview, and then we'll actually go to the website and take a look here. So I'll get those queued up here, and let's go ahead and see what is in the Crystal programming language wiki page. Now, interestingly, already we can see here that it's a language inspired by Ruby, which we've taken a look at in this series here, but it's a compiled language and it's also statically type checked. So that means we get a lot of the benefits, or today most folks are sort of agreeing, or the trend is that statically typed languages are great for safety, scalable systems, but we really, or at least I really liked the sort of freedom and the expressiveness of the Ruby syntax. So excited again to try out Crystal, and if it's compiled, that usually means we can get good performance, as compiled languages go down to machine code and can optimize for the target system that they're on. So scrolling down just a little bit here, we can see this is a relatively new, again, as far as programming languages go. And I say new programming languages are like less than 20 years old. So again, this one's relatively new here, but it's got multiple paradigms, object-oriented and concurrent. Interesting that that's highlighted here because honestly, these days, if I'm going to learn a new programming language, I want it to have some support for concurrency because, again, that's where the hardware is going. There's no free lunch, as Herb Sutter once said in the C++ community. You just have to know how to write programs for multiple CPUs in order to get more performance. So very cool to see that. So anyways, let's look a little bit at the history here. Looks like there was some development in 2011. Of course, it looks like the first release was in 2014. But it sort of looks like, yeah, maybe this was somebody who liked the Ruby language, but wanted a compiled, a little bit more type safety with the static type checking, and built Crystal. Interestingly, it looks like the initial name was Joy. I wonder why it was renamed. Maybe that name was already taken or something, or too common. I know a while ago there was like a Crystal 3D engine in the game programming world or something of that sort. So that's what that initially reminded me of when everyone kept talking about Crystal. I said, oh my gosh, is that project? But anyways, this programming language here, interesting to see that it was written in Ruby initially, and then of course rewritten in itself. That's a common thing called self-hosting. It's sort of this chicken and egg problem. We haven't talked about that too much on this series, but this idea of when you develop the language enough, you can kind of rewrite the language in the subset that you have, and then you're compiling your compiler within the language, which is kind of neat. But that's usually a big stage in the maturity of the programming language. Let's see here. Now it is part of the TOB index, which is, some metric. Let's go ahead and let's actually just search for the TOB index here. And I wonder where Crystal shows up today. Again, I don't care about popularity as far as programming languages go, but as far as 2024, let's see, is it starting to show up here? Let's search Crystal in the top 50. Maybe not quite yet. Just out of curiosity, let's see where Ruby is. I mean, Ruby is quite high here. Number 18 is it? Yeah, and as high as it was 16 recently. So again, Ruby or Ruby style language is quite popular here. Let's see a little bit more about Crystal here. So let's see. Compiles to much more efficient native code using LLVM. Okay. Now, again, compilers, this is pretty common. I mean, LLVM is a compiler framework as well as other things. So that means if we compile down to LLVM's intermediate representation, we're probably able to target basically every platform. That's what I'm guessing here. So that's kind of cool here. Let's see what else we got here. Let's see. So we give it a high level feel. It is garbage collected, which, garbage collected, especially if you're a compiled language, I don't know why that's controversial or as controversial. I know there's not having, if you're not doing allocation and hot loops, you're not going to have to worry about a garbage collection. So I actually like garbage collection. I mean, that's memory safety right there for free. Effectively, you don't have to worry about leaks and these types of things. So anyways, that's always a hot debate in the systems programming community, but until you run into performance problems and prove it's a garbage collection issue, I don't know. I wonder if how the Crystal community feels about it, but I tend to like software where I can focus on writing the software and have the memory managed for me. That's fine. Even in a gaming space, I know that's a little bit controversial, but I tend to like that. So it's got a Bohm collector here. Yeah, let's see here by Hans Bohm. I mean, this is one of the famous ones, of course. Here, let's see if we could go show Hans. Let's see if he's got a wiki page here. He must. Hans Bohm. I guess not here. But he probably deserves a wiki page. It looks like some of these other gentlemen here. Done a lot of different contributions to the programming language world. So, and I guess the Crystal Collector is based off that. So, okay, some other stuff. Concurrency model inspired by communicating sequential processes. Let's go ahead and take a look at this. Just learn a little bit more here and try to find an example. Let's see if maybe we'll just find a Crystal example there. And then it's got implementation of lightweight fibers and channels. Okay, inspired by Go. Okay, and Go, we know, was a language developed from the start to support for concurrency. So Go's found a niche, especially for writing backend and distributed systems. So very cool, very cool. Let's go ahead and we'll get a little of a sense of it from the wiki page here. But we've got our hello world. We've got a nice clean class here with simple syntax that is looking Ruby-esque, or even this is saying it's the exact same thing as in Ruby for writing this out, and then the classes as well here. Nice. We've got simple string interpolation here, it looks like, or some form of that. And let's see what else we've got here for the setting up a server here. Okay, so setting up the server, and we're going to do within some context. Okay, we got to figure out a little bit about this, what's going on here. Create a little HTTP server and an echo server here. Okay, so we'll have to try out some of these examples. I mean, this is pretty simple code for just getting things set up, so there must be nice library support. I wonder if there is interop with Ruby since it's inspired, or if folks translate it to Ruby, or how that works. So we'll have to learn a little bit about that. Let's see, in concurrencies using channels, okay, to communicate between fibers. So if we take a look at this, let's see, so we've got our channel here. We're going to spawn, let's see here, or do a few messages, I guess, and then send here, and then send, and then sort of receive. I mean, this is sort of like, in Go, again, how this works, or if you're familiar with like an observer pattern, this idea of just sending and receiving messages, makes things pretty easy here. Okay, so I think that gives a good overview, and nice to see here on the further reading. Looks like there are some texts and so on programming Crystal. Let's see, this is from the Pragmatic Programmers website, which I've gotten a few books from them. They do a nice job. The authors of these texts here. Let's see if there's a programming Crystal here. If it's still on the shelf. It says 2019. Here it is. Okay. So 2019, relatively recent book here. Again, nice to just see that there's some active resources, people in the community actually, enthusiastic and writing about the language. Again, just little things that I like to see as part of a language. So okay, let's go to the actual official website, a language for humans and computers. Okay, cool. So, that's kind of the idea. A lot of modern programming languages these days are leaning into being readable, expressive, friendly, compiling fast. There's a lot of these things that we care about for developing software, but the and computers, of course, we want it to run fast, right? That's the end of the day. My users want my software to be fast, right? They don't necessarily care if I wrote it in Crystal or whatever language, but kind of nice to see both, because if it's fun to write software, I'll write more of it, or you fine folks will. So anyways, looks like their past release 1.0 here, and I can't remember if I just saw on the wiki there was a 2 version on the way. But yeah, it looks like it's been in development for quite a while here. Again, heavily inspired by Ruby, so this might be the next like natural progression. I don't know if that's a thing where a lot of Ruby developers are switching over, but that's kind of cool. Let's hang on to this here. There's a link for learning here. Again, we like to just see I wonder if this is the same. Yeah, getting started here. Okay, so the same page. We'll hold on to that for a moment. Let's go to the install, just get that started, see how easy this is. Okay, bunch of different options here. What do we want to do? Do we want a tar? Let's see. I am on Ubuntu. Let's see how easy this is. Ubuntu. There it is. Okay, let's see. How do I install this? Okay, curl. And let's just go ahead and paste this in here. We got a little script. Type in my password here. And I'm on Ubuntu 18, which is basically at the end of its life here. So again, we won't be too harsh if things don't get set up 100% here. That's probably my fault. But let's give that a moment to run here. Otherwise, we'll go ahead and download the... oh, we can do this manually here. Let's see, did it work if I just type out like crystal? Oh, I've got a snap for it though. Let's see. Let's see what happened. Did I get some errors here? This might be an issue. Yeah, I think this is just an issue with my like old Ubuntu system. So let's just install the snap here. Looks like it's found here. Let's see, classic. That's fine as long as we get, say, version 1 or something. Let's see if we can get that set up. So again, probably time to upgrade my Ubuntu. Maybe that'll be a weekend project here. Oh, okay, but hey, that was easy. We got the newest version here. Okay, so good job. I give it a A+, or 10 out of 10, whatever rating you want to give for ease of install. Again, something important to me. So again, crystal version. Uh-oh, let's see here. Lib app protection, something. Let's see here. Seeing some libraries are missing. Okay, so, oh, okay, wait, it's telling me what to do here. So maybe I'll install these, but it is giving me crystal version 1.1, whatever. Let's maybe install those. Let's see if that'll do the trick here. Yeah, give it the full experience. So again, I'll still maintain my A+ rating. It told me what I was missing, and pretty good. So there's been some care put into these developer tools here. So nice job by the Crystal devs. Let's see if that looks like it mostly fixed those issues here. We'll have to figure out what's going on here. But again, I think if I update my Ubuntu or whatever, but it got rid of all the other errors here. So yeah, not too bad here. Let's see here. Crystal. Let's see if it gives us our help page. If I just run this here. Okay, so not too bad here. Okay, so let's go ahead and just take a look here at the rest of the page. We've got the syntax. And again, I'm not a super, you know, the only time I did Ruby really was once a long time ago, 13, 14 years ago, and then the first impression video we did of it. So I've got to remember a little bit about what was going on here. But I do remember as I started doing Ruby, I liked it more and more and more, and the syntax became very intuitive. So how we're sort of reading this block with the context here was pretty clean. So yeah, that's pretty cool here. Let's see what we got here. So the type system, it's statically typed, so any type errors will be caught by the compiler rather than failing on runtime. Again, I love that. You don't want to be running a project for an hour and just have it crash because of a type issue. I think folks have sort of gotten tired of that. So I'm leaning, I've always sort of leaned into compiled languages. If you watch my C, C++, D language series, all statically typed languages. Let's see, but it does have the built-in type inference. So, okay, most of the time you don't need to annotate with the type. So that's kind of nice. Again, concise, might lead itself towards more generic programming if I can just use this function or can infer different versions. I'll be curious to see what's going on with the generics. Maybe we should open this up. Let's see. I mean, there is a section right under here on generics. So it looks like it's maybe as simple as specifying the type here in the parentheses, which it is great. And I'm a fan of this syntax. I like from the D programming language just using the parentheses versus angular brackets. I think it's a lot cleaner. I don't know. It just reads better to me when you're sort of parameterizing the template parameter or for the generics, right? If I've got this type here in my box and I want to say, okay, the type's going to be an int32 or a string, that just reads nice. So Yeah, I'm buying into more the Ruby syntax. And I remember when I was making my Ruby video, and I'll say the same thing while looking at Crystal here. I don't know why this hasn't taken off more. Python sort of, I would say, is more popular, which is great first programming language to learn. But I think Ruby is actually really clean, and Crystal as well. Let's see what else we got here. All types are non-nillable. Okay, or null, I guess, in other languages, but nil. And variables are represented as a union between type and nil. Okay, so we've seen this show up in other programming languages where you have like an optional or something. Okay, so as a consequence, the compiler will automatically check for null references in compile time, helping prevent the dreadful $1 billion mistake. Yeah, we got to click on that for folks who haven't seen. Let's see if this brings the famous article here. Yeah, null references, the $1 billion mistake by Tony Hoare here. So again, going back and stating, yeah, returning null is basically bad from C. So it's saying, how many millions of dollars of time or opportunity cost or actual bugs or security issues this has caused. So yeah, we're seeing this in more modern programming languages. So that's kind of neat here. Okay, so let's go ahead and let's see. We can see from this previous example, interesting, error, undefined method upcase for nil. Okay, so it's basically saying here, right, we're either returning a string or nil, and we can't run this code here. I wonder how we fix it, though. And what if the compiler is just smart enough to know, or maybe generate all paths here or something, do some sort of control flow analysis to see what happens. I mean, I guess it's just figuring out, anyways, there could be a case where my string is not executed, right? And we just have my string here and it complains here. Okay. So interesting. We'll have to see how we catch those errors. For macros, let's see. Crystal's answer to metaprogramming is a powerful macro system, which ranges from basic templating, okay, fair, and AST inspection to types inspection and running arbitrary external programs. Okay, so let's take a look at this here briefly. And I'm guessing here with a function with a question after it means, now I wonder if this is something that we're able to run at like compile time, if that's what's going on with the macro system here. Let's see here. Or if this is just a, well, I guess, I mean, if I'm returning a bool, you would maybe put a question mark after the function here, but let's see here. Okay, so we'll have to look, or again, I'm not a Ruby programmer, so remind myself of this system here. But it looks like I'm able to do some sort of metaprogramming thing on the type here, see what the instance variables are, return a map here, and let's see, look at the name here, and see if it just includes this property here of a person. So, we've got the name here, maybe their age, and then true or false. Okay, so we'll have to read a little bit more about this. Okay, let's keep going, just kind of looking at some of the features, and we'll get to running some code here. So Crystal uses green threads called fibers to achieve its concurrency. Again, this is similar to like Go or Clojure. Okay, so we've looked at Go, haven't looked at Clojure yet, but maybe that's on the radar. And then without having to turn to shared memory or locks. Yeah, because the reality is, for a trivial program, using threads to communicate, it's it sort of makes intuitive sense. Threads, having a bunch of things execute in parallel, and this idea of shared memory, but getting it right or at scale, or once you have different subsystems working together with different programmers with different mental models, it's a little bit difficult. So having sort of more lightweight tasks or things that aren't relying on shared memory for concurrency tends to be a win. Or just the sort of async model where you can just which might have threads behind the scenes, but basically just be able to spawn different processes and have them do work on their own, tends to be, a good concurrency model as far as error prevention here. So let's go ahead and see. We're creating a channel here, looking at all the files, all the .text files in some directory here. And for each of those, we're going to, let's see, files.each do, and then we'll spawn, I'm assuming creating a new fiber here, or a green thread, read it, and then send the lines.size, And then I wonder here for, I guess I'm assuming this is going to be blocking, or this at this point we'll have a synchronization point where we can count the lines here. Because I guess, yeah, if we're just sending a bunch of messages, those will get queued up, and this will be sequential, but this isn't going to be the bottleneck, right? That takes a lot of time here. So, okay, very cool. I mean, this is actually a nice example. Maybe we can run this later or something similar. Okay, let's take a look at here. A lot of modern programming languages, right? The way for them to gain some traction, or one idea, right, is basically to be able to talk to C, because there's so many libraries in C. Other programming languages expose a C API or follow the C ABI application binary interface. So it looks like, yeah, they're trying to make it easy to call native libraries. That sounds like a smart thing again to do. So let's see here. So they create this lib here, and then you have an alias into the different types here, I guess. And basically set up whatever those functions are. So you're creating your version of the function, or creating a function pointer to the like library function here, it looks like, and setting up the type signature. Okay, I mean, this seems like reasonable stuff. There's probably tools to automate some of this here. Okay, let's see what else we got here. Dependencies. Okay, crystal libraries are packaged as shards. Okay, nice name. And distributed via Git. Okay, so this is kind of similar to in the D programming language or others, where you're basically your package manager is looking for like some GitHub repo to pull in a specific tagged version or whatever. So this totally seems reasonable here. Let's see. Built-in commands allow dependencies to be easily specified. This is just YAML here. Yeah, seems totally reasonable. Okay, so let's keep looking. We'll start writing some code here. We got a newsletter, so pretty active here. Let's see here. We got some companies creating crystal development tools. That's kind of interesting. We should see that here. What kind of tools are they making here? Crystal tool unreachable. Interesting. Oh, these are in the compiler. Great. We might have seen these briefly here. I wonder if we have different like tools here. Oh, we've got like a playground server. Okay, run a tool here. If I just type a crystal like tool here. Oh, cool. Oh, this is very cool. That's a very clean way. So there must be ways to write plugins for okay, showing like the macros expanded, formatting a project, showing the type hierarchy, dependencies and stuff. Okay, cool. It looks like they've got some nice infrastructure here. So we built crystal tool dependencies. Okay, very cool. Maybe we'll get to run one of those, but just kind of nice to see that that's in the ecosystem here. And there is a conference. Oh, cool. In Berlin, I guess, Crystal Conf here. So looking at this, yeah, we got some active folks here. Yeah, this is pretty cool. Again, I always look at these. I know maybe these are silly things to point out for a programming language. Yeah, some folks having fun. But I think it's good if there is an active community, and sometimes that means meeting in person, giving talks. Sometimes those talks go on YouTube or other places, so you can kind of just see what's going on from the experts, right? It's nice to hear from the development team. I think that's an important part of developing a programming language. Doesn't matter how big or small the community is necessarily, but just to see those active things going on. So that's cool here. And otherwise, it looks like, again, active releases here. Okay, so I think we've looked enough here. And there's a bunch of, let's see, communities, there's a forum, etc., etc. Let's check that out here. A lot of folks have gone basically to only Discord. Oh, there's even some jobs here that folks are looking for. But I like having a forum for archival purposes as well. It's easier for me to search, but I could be wrong about that, but nice to see the community. Alrighty, anyways, enough of looking at the language here. I think I'm excited enough to try this out. So let's look at the getting started here. And this is Crystal's reference book. Okay, so let's take a look at that here. And okay, got the compiler installed, and I'm pretty sure I can run the Crystal command. We'll see how it does here. I installed it through the snap package here. We saw about getting help, and let's write our first crystal file here. Okay, and let's just call this hello world. We'll just do our work there, and let's, before I get ahead of myself, move over the code to the left just so you can see everything that's going on. And let's go ahead and try it. Hello world, hello crystal. No semicolon needed. Crystal, hello world. Okay, it's working. And again, apologies, I don't know what this error is. That's probably my system that's misconfigured here. We're doing something interesting with a load preload command. I don't know what's going on. That's all right. But yep, just runs here. Simple enough here. Now I wonder if it's just basically, I mean, that's just running it like a scripting language, which is kind of nice, which was something I always liked in D, that I could do that. If I could basically just skip the compilation process and just run this like a scripting language just as fast, that's pretty nice here. No need to define a main function or something similar. Yeah, I could just run. Okay. Let's see. We have the introduction tour, and then maybe we'll get to those examples here. Okay, let's keep taking a look here. So we got our hello world. We did that. Okay. What else do we have? Oh, we can just run these examples here in case I don't type them out. That's great. Great job with your documentation, Crystal community. Okay, let's see. So that's our hello world. Let's look at variables here. Setting up. Okay, let's do a message. Hello, Mike. Hello, subscribers. How about that? Thanks for watching, folks. Let's go ahead and put that message here. Oops. See, I sneak a semicolon in here. Get that running. So yeah, simple enough here. Let's see. Name a variable always starts with lowercase, Unicode, or underscore. Okay. Interesting. Okay, so it's always snake case. As a typical convention, or that's what they prefer, snake case. Now let's see what happens if I made it a uppercase variable. I don't remember this from Ruby. Again, not a Ruby expert, but let's see what happens. Undefined local variable. Okay. I'll make that a little bit bigger here. Let's see how our error messages are doing here. Okay, I mean, that's pretty clear. It's telling us exactly what's going on. Okay, and that's pretty clear. I actually don't mind that, enforcing that in the language. Different languages, we've seen indentation and things, but kind of makes our code more uniform. I don't mind that there. Let's see the type. Okay. Oh, okay. I like this here. Type of variable is automatically inferred by the compiler, as noted. You can verify this with type of. Okay, cool. What's p exclamation? Oh, similar to puts, as it prints the value to the standard output, but also prints the expression in code. This is basically a useful tool for inspecting the state of a Crystal program and debugging. Oh, interesting. Okay, so let's do puts type of message, and then puts with this p exclamation thing here. Type of message. Okay, so let's see what kind of different output that gets us here. Get rid of our hello world just so we can see. So we got our message. It's a string, and then it's telling us type of message to string here. Okay, so that's printing the expression in the code. Okay, interesting. Now this must be useful for... well, we'll have to try this. What if I put type of, like, puts here? What expression does that give us here? It just tells us nil. Okay, I was wondering if that would show us the function signature here. So that's kind of interesting. Okay, but otherwise, I don't know, so we'll have to take a look at that here. Useful tool for inspecting the state of a Crystal program and debugging. Interesting. Okay, so I don't know what that's exactly giving me more of. Let's see, because I can infer, I see this is a string. I guess this is telling me what operation I was doing here and what the result is. I see. So maybe this is doing something if I do like a message plus a message or something that gives me a better inference here. But okay. Okay, so variables by default here look like they're mutable, so I can change this to whatever. Hello, Mike. Okay, no problems there. And it'll work with different types here. Type of the variable changes when a value of a different type is assigned. The compiler is smart enough to know which type it has at which point in the program. Interesting. Hey, I thought this was statically typed though, so let's go ahead and try that out. So now if I say message equals, 42, what's the type here? Okay, now it's an int 32. Interesting. So maybe it's just not as strictly typed, but I am able to sort of reassign these types here. Interesting. Okay. I don't know how I feel about that. I thought it was going to be... It's sort of good in that it's very flexible, but I might want some sort of warning if that happens here. Maybe I need to compile the program or something. Let's see here. Let's make that a little bit smaller just so we can read. I wonder if I try to build, if that causes a problem here. Crystal build. Let's see. Okay, so build, it gave me the executable, which was easy enough. Again, easy enough tool that I didn't have to do anything, right? I just typed in build and looked at their help. Okay, interesting. Okay, so I'll have to understand the type system a little bit better here with the tool here. Let's just keep running these. All right, let's look at some of the examples here. With math, we've got the numeric types. Little side thing that I see here, I like that when we are getting the types though, it's getting like int 32 in the explicit widths of the type, so I know how many bits they are. I like that. I don't want to, I want every type to know exactly how many bits it is. Or the alternative that I want is I want to know an int is always 4 bytes, for example. That's also fine. I'm fine with that. But I like seeing the size here. And especially in a language that's inferring the type for me, that's even better. It's more precise, right? That I want to know what this is. Okay, let's see what else we got here with our types. Looks like the default integer type is a 32-bit integer. Default, we have like doubles in other languages, or a float 64. Okay. Oh, and they've got the nice underscore syntax, which I like. For delineating or telling, it's hard to read, when you write 100,000, how many zeros there are versus a million or something. So I like that here. Yeah, let's just run this here. So floating point values with a decimal point, integers values don't. Okay. Let's see here. So that's just okay. Yeah, stating the usual. Integers don't have a decimal. Okay, and there's a bunch of other different types here, right? You could probably optimize or have a 16-bit or whatever, but that's fine. Okay, equality here. Let's go ahead and try some of these out here. We'll go ahead and print, and given the context here, we've got these comma separated so we can kind of string these together here, but let's just see if we get one here. This just results in true for the puts here, but showing us the expression here. Okay. So besides our equality, we've got the standard equality operators. Ooh, they've got the spaceship operator as well here. So kind of nice little shortcut as it's stating here. Returning 0 if they're equal, 1 if this one's bigger, and -1 if the other side is larger. Which is sort of what, like, if you look at like star compare or something in C, I believe that's the similar behavior. Alrighty, and then we got our other operators here. Ooh, floor division, okay, with 2 slashes, and modulus, okay, everything kind of standard there. Operator precedence looks standard. We got a bunch of number methods here. So again, these are pretty standard things here. I wonder if I do even without the question mark here. Let's go ahead and refresh that because we don't see that as often. Let's go ahead and say 5.even. Let's see what that does here. Is that going to error out? Error, undefined method. Now if I put the question mark here. Let's see here. Okay, yeah, 5 is not even. We return false. And again, I believe in Ruby, the question mark is just like a stylistic thing telling you, do I return a Boolean value? Okay, because we're asking a yes or no question effectively to the computer. So yeah, just something to remember there for me. Okay, and then we got our math functions, constants built in. Yeah, nice stuff here. I mean, I haven't imported anything as far as like a math library. In fact, let's just go ahead and run one of these as well. Let's see, math. Let's do pi because I'm pretty familiar with what the outputs there. Okay, now it is oh, I did uppercase. Hey, it gave me a pretty good error message there. Again, plus points for the language on the debugging there. So it's better if I make some mistakes here. And let's go ahead and run that here. And we get 3.1, whatever. Now it's giving me the value here, but let's go ahead and do type of. Let's see, is that a 64, a float 64 by default? Right? Yes. Okay, great. So we're testing our assumptions here. Let's look at strings. Okay, as mentioned, yep, we got the interpolation here, so we could just write out the variables, very clean. So let's see, we could do put message again, and then I could put in, let's see, the hashtag mark. Different languages use like the $sign or whatever to put in things, but yeah, this is pretty clean here. I like this as a language feature. It tends to make things really clean. And if you're doing stuff in a language like this, where maybe you're writing like a SQL query, excuse me, and want to like generate a string or something like this, it's just very easy without having to do like plus and minus and casting to a string type and so on. Just fitting in the value there works really nicely here. So I like that here. All right, we've got escaping characters, Unicode support. Okay, so we can put out smiley faces or whatever. All right, cool. And let's see what's this here. Okay, so if we want to do a transformation on the string and make it uppercase, okay, we've got a few similar methods here that we can do so. Let's see here. Let's change our message out of 42 and just do one of these here. Let's do like camel case here. Let's see what happens to our string. Hello again. Hello, Mike. Okay, so it made the first thing uppercase. Yeah, not too bad here. Okay, looks good to me. Information. Okay, we can start querying some stuff like about the size and so on. Check if it's empty. Okay, so these are like classic things here. And string comparison just with the equals operator. Okay, this is pretty nice. It looks like there's some different ways to call compare, and then you can pass in your function or comparator or your strategy, again, depending on how you do this, but just provide a method here to check case sensitive is my message, hello world. Case insensitive, all lowercase for both these strings, then it's true or false. Okay. Okay, so yeah, nice. Let's see what else we got here. Yeah, some other handy string functions here. Includes. Let's go ahead and run some of these here. Let's do this here. We'll do message dot includes, and for us, hello. Go ahead and do that, and we should get a, let's see, true. It does, of course it does. It has hello subscribers or hello Mike. Starts with, and we can index into strings. Let's see here. Okay, all of this is looking pretty clean to me here. Okay, and then we could have different arguments. Now notice that the arguments in these methods here are named, which is kind of nice here. Again, there might be multiple, or now I wonder if they're named arguments, we can put these in different orders here. That's one of the advantages of having named arguments for your methods. So that's kind of interesting. It maybe makes things a little bit more flexible for using these types of functions. But I wonder if that also benefits the macro system as well. But anyways, just some nice observations here. Okay, so they're just kind of going through all the different string operations. So this is great here. Let's see what else we got here. Index accessor. Let's see. We can reference a substring by character and size. Indices. Okay, there's a zero index language. Let's go ahead and do that here. Let's put out with message 0 and 5. Let's see what happens here. Okay, so we'll check for hello, and then we'll write out hello here, starting from 0 and going to 5 here. Now let's see here. First argument specifies the index of the first character, and the second is just the length of the substring. Okay, so we're doing like a string slice here. Trying to see if there was anything else here, but this is all stuff that, you know, we are sort of used to doing here. Okay, some substitution. Okay, interesting here. Okay, I was wondering, yeah, if we can do, let's see. Okay, yeah. Okay, so let's not skip this here. There's an easier way. I was gonna say, yeah, this is like the classic C way of, you know, indexing into array, but I like when we have like ... in the range. So let's just do like 0 to 5 here. That's a little bit cleaner. I like this. You get used to using this when you have languages that just lets you use like the ... And then you can compute the index or whatever here. So yeah, that's much more cleaner here. And then let's see, I guess I wonder if I put in -2, here, let's do -3 or something. So it should do like hello mi maybe. Let's see here. Or hello mik. Yep, that's getting rid of 2 characters. Oh, and I suppose the end. So from the end of the length here. The extra null character or something. Okay. Substitution. Okay, so lots of nice built-in string things. Let's see here. Primitive types here. Again, we have nil. Let's see. And remember, let's see. It returns nil if the substring does not exist in the search. It has no index. Okay, so we'll have to learn about how to handle that. Maybe we'll get to that. I've got bool, Boolean algebra stuff, truthiness. Okay, these are all of our standard things. But, you know, we've looked at these. So if you've been watching all these videos, it is just interesting sometimes to see how the authors or different programming language folks, you know, put together the documentation to explain the language, right? Even though these are different things that we've probably seen or are very familiar with, right? Expressing it as truthiness, that's how I learned it in like a discrete mathematics class. And you build these like truth tables and stuff. So the truthiness is just kind of interesting versus like other languages, you know, this is presented as the conditional operators, then you can combine these and so on. But yeah, actually seeing conjunction, disjunction, inequivalence and equivalence, kind of nice to just refresh those words every once in a while. So anyways, I am going to kind of speed through this so we can get to some of the interesting stuff here. But we've got these if statements. Oh, there's interesting unless here, which expresses the opposite here. Let's see, unless x is equivalent to if not x. Okay. I don't know how I feel about that. Maybe I wonder how often folks use unless versus if. That would be something I have to get used to, but maybe it's cleaner, right? Somebody's made that decision to write that code. Let's see here. Okay, and we can check if our index is nil and then handle that case here. Okay. Because it's returning true or false by convention, we've got a question mark after it. Okay, let's see. Else statements, more branches, if, else if, shorting to EL versus elif in Python. So if you're converting code, make sure to put that extra S in there. Let's see what else we got here. Loops. Yeah, we got our typical countdown example with the string interpolation. Very nice. Infinite loops. And let's see what else we got here. Skipping and breaking. Yeah, all standard stuff here. Just kind of going through till I see something. Oops. Yeah, let's take a look at methods here. Okay, yeah, let's write a function here for say hello. With define here, so sort of, or the def statement here. Puts hello Mike and end, and let's do our function call. No need for empty parentheses, but I guess we can do it. What they're telling us. So go ahead and let that run here. We can provide arguments here. So there's our function being called here, no problem, twice. And pretty simple to specify the parameters here. Okay, get set them to default arguments. Yep, so that's nice. All right, let's see, type restrictions here. Okay, so we can't specify a type here. Otherwise, you know, and I wonder if this is the right way to approach code. You know, most languages, the default, what's easy to do is write code So let's go ahead and add something to our say hello, and we're going to say the the name of the person, which is going to be represented by a string, and then we'll use the string interpolation here. But what I'm saying here is the default in many programming languages, C, C++, Java, etc., C#, D, is to provide a type here, which is good, right? We want to think about how data is flowing. But what also is good is generic code, right? So the default, depending on what you want to emphasize, is to not have this type annotation, and you get sort of the default code for free. I mean, I guess that's a good thing with these more dynamic languages like Ruby and Python, in which Crystal is influenced. So I'm kind of torn between that, because as someone who writes libraries, it is kind of nice to have a generic type that just works on everything. So anyway, it's just something to think about. It's nice to put your compiler to work and not you to work, doing extra work to write generic code. So you just kind of get that for free, it looks like. Yeah, so you got overloads if you do have different types. And returning a value, let's see, by default, it's the value of the last expression in the method. Yep. But we can explicitly return something. Okay. Let's see what else here. The return type, and it can be specified. Okay, with colon at the end here. So I don't know if we want to return like an int 32, which is always return 42. It's not going to really do anything. Let's see here. What did it complain about here? Error, space required before colon in the type. Okay. Here, let's see. And then what else here? Okay, wrong number of arguments. Let's make this a default argument. And do I specify it here? Let's say it's always me. Well, you have to talk to. Let's see here. Let's go back to our default arguments. Now, it's giving us helpful messages here. But let's see here. Overloading. And okay. Recipient equals. Yeah, no, that looks okay. But I wonder if I specify a default argument, it's just inferring, excuse me, the type here. Does it know that's just always string then? Yeah, I guess that makes sense here. And then I could check what the type is or something. And there was one warning here. Let's see, warning, space required before colon in return. Okay. Interesting. So it's giving me warnings on formatting errors. Okay, so that's something that I don't think we've seen. Most programming languages, again, and if I just don't remember the Ruby, will enforce things like indentation and so on. Like when we've looked at, like I think Nim, and of course Python's famous for this. So, but not having the spaces, and probably making it in warnings probably the right default. That way you don't. Because you don't want to block your users from getting fast feedback necessarily if they're just wanting to run their code like I am. But eventually, before I check it into like the GitHub repo with other teammates, you probably want it formatted correctly. So anyways, okay, let's kind of keep going through this here. Okay, let's see. Oh, we're at the manuals now, using the compilers and so on. Okay, looks like we got through like the basic language here. Let's see, that was a tutorial, the language introduction. Let's see the object-oriented stuff here. And then I want to do the concurrency stuff here. Or let's see, they build like a little command line application or something. Let's see here. Maybe we can just run the server here. Let's see, is this all we need here? We'll create our server, have it listening. Okay, let's see here. Maybe we'll want to find another guide and write some actual code here. Because otherwise this isn't too interesting. I mean, this is here. Well, let's just do it here. Let's paste this in here. And run the application. Let's see, require. We'll create our server. I'll just do this at the start because it's just going to be listening here. And let's see if it starts running here. I mean, this is always a nice test to see in the language how easy it is to get stuff up and running. And let's see, where did I create this? What have I done here? I'm assuming it's on, okay, so let's open this link up here. Okay, so we created a little server and it is running. Let's see here. Now it's telling us hello world. The time. Let's see. Oh, there it is. Okay, the time is time local. Okay, cool. So that's what the server's response is. And it's just listing every time we connect. Okay. So that's kind of cool. You can create your little server here. Let's take a look at some of the OO stuff and the concurrency here. Maybe we could just run literally the example from the concurrency here. Let's build this as a little program here. All right. Let's go ahead and just kill this and do concurrency. Paste. And then let's take a look at this code here. Okay. So first, let's see if it just runs here, Crystal. And let's see, concurrency should run. I mean, this is their example. 0, we don't have any text files, so let's create a text file here. Text.txt. Hello. My name is Mike with 5 lines. Let's go ahead and create one more. Text 1. Yo. Hello. Okay, now let's give this a try here. Should run pretty fast here. We got 7 total lines. For those counting, or you can rewind, that is the correct answer. And let's see here. Let's actually build this program here. And if I just run concurrency, I mean, it runs instantly. It's a tiny program. So kind of hard to run this here. Let's go to my home directory. Let's see here. How to do this? Let's move concurrency to my home directory, move into my home directory, and run that program. Okay, so whatever text files I have there, I computed really quickly. So not bad. And as far as the syntax goes with this, let's again try to understand here. So we're going to create this channel here, which is a built-in type. I'm not requiring anything, so that's sort of a nice thing to see that's built in, right? It's, again, like they said, influenced by Go, the Go routines. So create one of those. The type of message, I suppose that it's sending back and forth is just an integer, right? Because we're counting lines. And okay, and then we've got our shared value here. Now I wonder if per like file, this is thread local. So total lines is just sort of local here. I'll have to think about that a little bit. That sort of makes sense. And then let's see, we look at or gather everything, and then we're still sequentially running. And then this is the concurrent part where we're doing spawn. And then we're doing in a loop here, lines equal to, okay, for each file, yeah, just opening it up and then sending a channel the line size here. Okay, so it's sort of queuing that up here for each file that we have here. Now let's do a little bit of inference here, just so I can try to understand what's going on here. Let's see if I do this p exclamation mark type of thing, which is what we've learned so far. And then let's go ahead and run concurrency. Just gonna run it straight here. A little bit faster if we can pilot. Okay, but this is giving us an array of strings here, and then we're just operating on that collection here, dot each. Okay, and then doing do, and then for each file f, which is part of files, one of these strings here, we're reading the file, creating this file object and just running read lines on it, and then in our channel sending the lines dot size here from the file that we read. Okay, yeah, this code makes more sense now. Kind of nice to go through it and think about it. Again, as I'm rediscovering, same thing for those who watched me go through the Ruby video. I actually kind of like how this reads here. Files that each do. And again, dare I say there was always also something similar in Go like this. Again, Go, when I just looked at the previous video in this series, also very kind of readable. I mean, this is trivial. You know, as trivial as a concurrency model as you can make it with the channels here, which is sort of like, again, if you're in C++ or Java land or D or whatever, creating an observer pattern, although I guess D has message passing as well. built in. So that's also pretty trivial. But okay, pretty nice, the concurrency model here. Let's see what else to look at here. Now, it said it was an object-oriented programming language. I mean, maybe that's just exactly the same as Ruby here. So I guess we can just take a look at here. And this is the macros. So, I mean, can just take a look at this. We already kind of looked at this, so maybe we'll just wrap things up and look at their the rest of their guides here for writing packages and tips here. I'm kind of curious. Oh, they've got a performance guide here on avoiding allocations and stuff. I wonder if there's a tool built in. Let's actually, that was one of the things we mentioned here. If I just run Crystal here, let's see what happens when I just run one of those tools. It's kind of interesting to see the ecosystem here. Let's see here. So Crystal tool, let's see what I have here. Dependencies. Okay, and then if I just pass in a file, let's see, is that do the trick? There's nothing here. Let's see here. In our other file, hello world, we did require HTTP server, so let's see if that shows up with something. Let's see here. Maybe that's not the right way to, maybe there's just no dependencies. Let's see what else we have here under Crystal tool. We can format, show the type hierarchy. Okay, let's see what that does here. Just run this on our little hello world example on the left side. Hierarchy. Unknown tool. Let's see, I probably didn't spell it right. Hierarchy. Oh boy, let's see. Let's paste that in there. Oh, maybe it's not ready for use here. Okay, there we go. Okay, cool, interesting. Here, let's scroll up, try to see what we're looking at here. Now this is kind of interesting. I mean, this is giving us probably a bunch of the runtime and other stuff here, so it's giving us like everything here. Yeah, it's telling us about the GC, all the included libraries. I mean, this is probably interesting too if you, I mean, there's probably a way to filter this again. Let's see if I just run this here. Oh yeah, it is. We do have options here. Filter types by name. Let's see. I don't know what a good name is here. Like server, would we find that? I don't know. Is that a type here? This HTTP object? Yeah, I don't know if I'm gonna be able to figure that out. But that's kind of neat. And there's probably a nice way. Let's just look at this one more time. Let me do like URI maybe. But if you know the structure you're looking at, and this is probably useful for their macro system if you're just trying to do some of the, maybe verify that you're able to get some of the fields, or if it's a type that you haven't built to look at, you know, the different objects and stuff. So this is kind of neat to see all this in one place here. So there are some interesting tools here. Let's see what else we got here. Oh, unreachable. Interesting. Let's run this on our server application. Unreachable. And concurrency. Is there anything unreachable? How did we do? Nope, nothing unreachable here. I mean, this just runs, I guess. What about for hello world? We've got our listener server. It is blocking, but it is doing an analysis. So that's kind of cool. I mean, it looks like there's infrastructure. I wonder if those are more LLVM or Clang tools, or if they've got some other infrastructure on that. You know, they've got some stuff here on writing, let's see, shards, which are packages, but I wonder if there's stuff on writing tools. There must be at the, you know, conference or reading the blog to see how those other tools were built. So anyways, I think we're at about an hour here. I'm going to go ahead and wrap this up here. Let's see what else there is here, actually. Before I wrap this up, I just want to see if there's other like online playgrounds, developer news, maybe checking out the blog here just to see if what projects have been done from Crystal here. Oh, music, Crystal Game. Yeah, perfect. Interview with a contributor here, Ramilia Scarlett. Let's see here. Okay. Let's see. So they've done some projects on like music players or formatters here, sound tools. And a game engine as well. Okay. Oh, doing like video game music. Okay, cool. You made games, games in Crystal. Yeah, okay. Oh, unfinished port of Doom. Okay, great. That would be cool to see because again, I think this could be interesting language for rapidly prototyping stuff. But I imagine anybody who's doing Ruby stuff, especially for like web development, if you're able to get some of the compiled speed from this language, that might be a win. I mean, these are things that are going to save you money, maybe serve your customers' requests faster on the web or in the cloud. So Crystal, overall, very impressed. Nice language here. Looks like it's gone through a lot of development. It's got the conference with lots of cool and exciting things. It looks like that's going on, and maybe a way to go forward is to watch some of these recordings here. Quite a bit, a few talks here, which looks nice here. And this is answering some of my other questions here, like using it for computational chemistry. This sounds like cool stuff. So, anyways. Hope you folks enjoyed this, the Crystal programming language, taking a look at, again, a language that's been on my radar for a long time, and I'm happy to have finally gotten to take a look at it, as many of you folks have requested actually looking at it. And have to say that I'll probably take more of a look at Crystal at some point, and would encourage you to install it. It was super easy to get set up and running. And if you're a Ruby enthusiast, this might be, another language to add to your arsenal to get some of that compiled speed or whatever. I do know Ruby has like Ruby that runs on the JVM. Maybe there's compiled versions as well, but this looks like a meaningful alternative and a active project that is doing some cool things. So with that said, folks, hope you're enjoying this series. As always, if you are enjoying, make sure to give a thumbs up or subscribe. And otherwise, let me know what your thoughts are in the discussion below about Crystal. We've been having lots of fun discussions in this series. So I've been enjoying that. Anyways, folks, with that said, thanks as always for your time and attention. I'll look forward to seeing you in the next one. What's the next language going to be? Well, we'll find out soon.